Welcome to chemistry classes. In this video we are going to discuss about thermal energy and intermolecular force of attraction. Relation between thermal energy and intermolecular force of attraction. Okay, grade 11 chemistry states of matter part 2. Here we have to discuss relation between thermal energy and intermolecular force of attraction. Clear? Also we will discuss here different gases laws. Okay, so let us check here thermal energy. In previous video we discussed different intermolecular force of attraction. Intermolecular force of attraction, this force of attraction keep molecules together. Okay, adjacent particles attract each other, and this force of attraction keep molecules together. But thermal energy means energy possessed by moving particle in a body. When you take a body, there is many particles, and these particles moving freely and randomly in different states of matter. Particles are moving. Okay, and the energy possessed by moving particle in a substance, this energy called thermal energy. Thermal energy also called thermal energy mean it is directly proportional to temperature of that substance. Thermal energy directly proportional to temperature. Also thermal energy mean it is a measure of average kinetic energy of the substance. So you understand, thermal energy mean energy possessed by a moving particle. Okay, moving particles means substance, it contain atoms or molecule. These atoms or molecules moving freely and randomly. Okay, this movement produce energy, and this energy is thermal energy. This thermal energy is directly proportional to temperature of that substance. Thermal energy is a measure of kinetic energy of that substance. Clear? So this is the basic information about thermal energy. Next one, we have to understand here thermal energy in different states of matter. When you take solid state, liquid state and gaseous state, we can see here in solid state particles are tightly packed. Particles are tightly packed mean here intermolecular force of attraction between particles are very high, and particles are tightly packed, and movement of particles are very less movement of particles in solid state. So in solid state they have less thermal energy. When you move from solid state to liquid state, in liquid state intermolecular forces comparatively less compared to solid state. Intermolecular forces less, and particles can move. Okay, and they produce an energy, and they have higher thermal energy compared to solid state. Liquid states have higher thermal energy. Okay, again we are coming to gaseous state. Particles, intermolecular force of attraction between particles are very less, and they moving freely and randomly. That's why gaseous state they have higher kinetic energy. Okay, so higher thermal energy or higher kinetic energy. So when you are moving from solid state to gaseous state, here solid state thermal energy very less. Okay, then increases to liquid state, again increases. So from solid state to gaseous state thermal energy increases. So synchron, intermolecular force decreases from solid state to gaseous state. Okay, so intermolecular force is higher in solid state, least in gaseous state. Thermal energy higher in gaseous state, least in solid state. So this is the relation between intermolecular force and thermal energy in different states of matter. Clear? Okay, next one here we have to discuss here, we have to focus more about gaseous state. So here we will focus more about gaseous state. Okay, so here the name of chapter solid state, but we will focus gaseous state, different gaseous laws, etc. Okay, so here gaseous state, when you take periodic table you can see many gases: oxygen, nitrogen, hydrogen, Okay, also there are different gases, noble gases, helium, neon, argon. These are gaseous state in periodic table. Okay, and here we have to understand, you learned these things before, physical properties of gaseous state, different physical properties of gaseous state. Actually gases are invisible matter, that is gaseous state. Okay, so here different physical properties of gaseous state. Here gases, they have no definite shape and volume. Okay, we know solid state particles are tightly packed, they have definite shape and mass, but here in gaseous state they have no definite shape or volume. Clear? Also here gaseous state, I told you before, in gaseous state intermolecular force of attraction is very less. Intermolecular force of attraction is very less in gaseous state, and this gaseous state are moving freely and randomly. During their motion, this gaseous state hit with wall of container. Look here, imagine a container. Okay, imagine one cylinder, closed cylinder. This is one closed cylinder with different gases. Here one closed cylinder with gases, and here many gaseous particles, and intermolecular force of attraction between these gaseous particles are very less. That's why gaseous particles are continuously moving freely and randomly. During their motion, these gaseous particles will hit with wall of container. Gaseous particles will hit with wall of container. Okay, and it produce pressure. Gaseous produce pressure. Why gaseous produce pressure? In gaseous, intermolecular force of attraction between adjacent particles very less. Gas particles moving freely and randomly. During their motion, these gas particles hit each other. Also they will hit with wall of container, and they exert a pressure. Gas particles exert a pressure. Okay. So here volume, gases, they have no definite shape and volume. Gaseous particle produce pressure. Compared to solid state and liquid state, gases have lower density. They have lower density. Also we discussed intermolecular force of attraction between gases are very less. So these are the different physical properties. They exert pressure. They have no definite shape and volume. They have less density. Intermolecular force is very less. Clear? Okay, so here we discussed gaseous state. Gaseous state, different properties of gaseous state we discussed. Next one, we have to discuss here gas laws. We have to discuss here different gas laws. Okay, Boyle's law, Charles' law, Gay-Lussac law, Avogadro's law. These are the different gases laws we have to discuss here. First one, we can discuss here Boyle's law. Boyle's law. Here Boyle's law means it is pressure, volume, temperature. You have to remember this. Boyle's law means pressure volume relation. Okay, according to Boyle's law, pressure of a given mass of substance is inversely proportional to volume. Pressure of a given mass of substance, pressure of a given mass of gas is inversely proportional to volume at constant temperature. Temperature must be constant. This is called Boyle's law. Pressure of a given mass of gas inversely proportional to volume at constant pressure. A constant temperature. Okay, constant temperature. Okay, this is called Boyle's law. So P directly proportional to 1 by V. We can change directly proportional to equal to. So we have to multiply with one constant. So we can write P equal to K1 into 1 by V. K1, it is proportionality constant. Okay. So here P equal to K1 divided by V. So PV equal to K1. Okay. P equal to K1 by V. So PV, bring V over here. So you can write PV equal to K1. PV equal to K1. Clear? So consider Consider at a constant temperature, pressure of a gas is P1, volume is V1. This gas is expanded. After expansion, pressure changes to P2, volume changes to V2. Here consider a fixed amount of gas at constant temperature T. Temperature is constant. Okay, its pressure is, initial pressure is P1, initial volume is V1, P1, V1, initial pressure and volume. The gas is expanded. After expansion, pressure changes to P2, volume changes to V2. Okay, we know PV equal to a constant. So we can write P1 V1 equal to P2 V2. Okay, P1 V1 equal to P2 V2. You can rearrange this equation. Look here, P1 V1 equal to P2 V2. Bring P2 that side. So P1 divided by P2 equal to P2 divided by P1. Okay, P1 divided by P2 equal to V2 divided by V1. So remember this also. So you got many equation here. PV equal to one constant. P1 V1 equal to P2 V2. Also P1 by P2 equal to V2 divided by V1. Okay, if you know this equation, from this equation you can write it. Clear? So this is about Boyle's law. So according to Boyle's law, pressure of a given mass of gas is inversely proportional to volume at constant temperature. We can draw this graphically. Okay, so this graph is here in Boyle's law. We use constant temperature. Constant temperature mean we will say isotherm. Isotherm mean constant temperature. Isobar mean bar related to pressure, barometer pressure. So isobar mean constant pressure. Okay, isochor constant volume. So remember this, isotherm. Therm mean related to temperature, thermometer, therm. So here isotherm constant temperature, isobar constant pressure, isochor constant volume. Clear? So here isotherm, isotherm mean here pressure against volume. We are drawing graph pressure against volume. Here constant temperature. Temperature must be constant. We know pressure and volume is inversely proportional. So look here, at a high pressure volume will be less. At a high volume pressure will be less. Okay, so pressure and volume is inversely proportional. So when you draw pressure and volume graph, the curve will be obtained. Okay, so there are three different curves at three different temperature. This is for 200 Kelvin, 400 Kelvin, 600 Kelvin. When you increase temperature, the curve will be shift upward. The curve will be shift upward at a higher temperature. Okay. So this is isotherm. So pressure against volume. Also we can draw pressure against 1 by V. Look here. Pressure against 1 by V directly proportional. Pressure and volume inversely proportional. Pressure and 1 by V directly proportional. So when you draw a graph, pressure against 1 by V. Here in y-axis, this is x-axis. In x-axis it is 1 by V. When you draw pressure against 1 by V, you will get straight line. Pressure against volume, there will be curve. Okay, so here there are three lines, three straight line at three different temperature. I told you when you increase temperature, the line will shift upward. When you increase temperature, here the curve will be shift upward. So here T1, T2, T3, which will be higher temperature. T3 will be higher temperature. At a higher temperature, the line will shift upward. So you can say here T3 is higher than T2 is higher than T1. Okay, T3 is higher temperature. Clear? Also we discuss here PV equal to constant K1 or P equal to K1 into 1 by V. K1 mean it is proportionality constant, and this value K1, value of K1 varies with the temperature. When you change temperature, the value of constant K1 also change. Clear? Okay, so here last part of Boyle's law we have to discuss here density related to density. We know density means mass per unit volume. That is density, mass per unit volume, mass of a substance in unit volume. So density is equal to m by v. We know Pv equal to constant K1. So V equal to K1 divided by P. Look here, density equal to mass by volume. V equal to, you will get an equation for V. Pv equal to K1. V equal to K1 by P. K1 divided by P. Substitute this value of V over here. So density equal to M by K1. Look here, K1 by P. K1 by P. This P will be upward. So M by K1 into P. M by K1 into P. Okay. So here a new constant, mass of the substance will be constant. So M by K1 we can write K dash. Okay. So density equal to K dash P. What is K dash? K dash is new constant. It is mass by K1. Okay, so here according to Boyle's law, density equal to K dash P, or you can say according to Boyle's law, density is equal to M by K1 into P. M by K1 into P. K1 is proportionality constant. Here K dash is mass by K1, M by K1. Okay, so these are the things we have to remember about Boyle's law. Clear? Okay, so here we discuss Boyle's law. According to Boyle's law, pressure is inversely proportional to volume. Pressure inversely proportional to volume at constant temperature. Boyle's law means it is pressure volume relation. Next one, we have to discuss here Charles law. Next one, Charles law. Second law here in gaseous law. Second one, Charles law. Charles law means it is volume temperature relation. Okay, Charles law, it is volume temperature relation. According to Charles law, volume is directly proportional to temperature. According to Charles law, volume of a fixed amount of gas is directly proportional to temperature at constant pressure. The previous one, constant temperature, isotherm. Now constant pressure, isobar. Okay, so isobar, it is related to Charles law, isobar. Okay, so look here, according to Charles law, it is here Charles law, it is volume temperature relation. Charles did many experiments and he found that when we increase temperature, volume of a fixed amount of gas also increases. When we increase temperature, volume of a fixed amount of gas also increases. When we decrease temperature, volume of fixed amount of gas also decreases. Increase temperature, volume increases. Also decrease temperature, volume also decreases. Also, Charles found that when we increase temperature by 1 degree Celsius, volume of a gas increase by 1 divided by 273.15 unit. You increase temperature 1 degree Celsius, then volume of gas increase by 1 divided by 273.15. 1 by 273.15 unit. Okay. Here volume of gas increase from its initial volume. Imagine its initial volume is 10 volume. Okay. Then it's when you increase temperature by 1 degree Celsius, volume increases by 10 plus 1 by 273.15. So volume will be increased by 1 by 273.15. Okay. Here from his experiment he derived one equation. Okay. Imagine volume of a fixed amount of gas V0 at 0 degrees Celsius and volume of that gas Vt at T temperature. V0 volume of gas at 0 degrees Celsius, Vt volume of that gas at temperature T. And he derived one equation Vt Vt mean volume of gas at temperature T is equal to V0 plus T divided by 273.15 into V0. He derived one equation like this. Vt equal to V0 plus T divided by 273.15 into V0. Okay, this is Vt. He derived this equation. Look here V0 one term, here also 1 0. V0 is there. So we can write this equation in different way. We can take V0 outside. So V0 outside. Okay, then 1 plus T divided by 273.15. We can write this equation like this. Vt equal to V0 plus Vt equal to V0 into 1 plus T divided by 273.15. Clear? So here Charles did many experiments. From this experiment he found that when temperature increased by 1 degree Celsius, its volume increased 1 divided by 273.15 unit. Okay, from this observation he introduced another scale of temperature. According to this scale of temperature, imagine 0 degree Celsius. 0 degree Celsius will be equal to temperature 0 plus 273.15. Why here 273.15? He found that when we increase temperature 1 degree Celsius, volume also increase by 1 divided by 273.15. Based on this observation, is new scale of temperature 0 degree Celsius equal to 0 plus 273.15. Okay, and unit of this new temperature is Kelvin. So 0 degree Celsius equal to 0 plus 273.15 Kelvin. Similarly, 25 degrees Celsius equal to 25 degrees Celsius mean 25 plus 273.15. So it will be 298.15 Kelvin. Okay, so 30 degrees Celsius equal to 30 plus 273.15. So you can convert all degrees Celsius according to new temperature scale, Kelvin scale. You can add this. Okay, 50 degrees Celsius mean 50 plus 273.15. So here a new temperature scale is introduced. This new temperature scale also called Kelvin temperature scale. That's why the unit of this new temperature scale Kelvin temperature scale. Also called absolute temperature scale. Kelvin temperature scale, absolute temperature scale, or thermodynamic scale, absolute temperature scale, Kelvin temperature scale. These are the different names of this new temperature scale. Clear? Now see here, we derived this equation. I told you Charles derived this equation based on his experiment. Vt equal to V0 into 1 plus T divided by 273.15. Okay, so you can do one thing here. Here this is 1 and multiply this term over here. So what happened here? 1 time 273.15 plus T. Okay, you multiply this term here. So 273.15 plus T whole divided by 273.15. Okay, you can rearrange this equation like this after multiplication. Okay, so here I told you here, look here, T degree Celsius plus 273.15 mean it is T. Okay, here you can say it is TT. Here you can write it like this, TT. Okay, similarly here 0 degrees Celsius mean you can write like this, T0. T0 means 0 degrees plus 273.15. Here you can say this is T25. T25 mean 25 plus 273.15. So you come to this point. Now look here 273.15 plus t. So you can change this t 273.15 plus t, that is tt. Okay, here only 273.15 means plus 0. 273.15 plus 0, that is 273.15. So you can change this temperature T0. Okay, so here 273.15 plus T, TT. 273.15 plus 0, T0. So we changed this like this. Vt equal to V0 times Tt divided by T0. We changed it like this. Okay, then rearrange this equation. Bring V0 over here. So you can write Vt divided by V0 equal to Tt divided by T0. Okay, Vt divided by V0, Tt divided by T0. Vt, V0. This is initial volume, this is final volume. This is initial temperature, this is final temperature. Okay, first volume, second volume. First temperature, second temperature. So you can write here V1 divided by V2 equal to T2 divided by T1. Okay, look here, V2 divided by V1, T2 divided by T1, because this is first volume, second volume. V0 mean initial, Vt mean volume at temperature T. Okay, this is initial temperature, this is final temperature. So V2 by V1 equal to T2 divided by T1. Clear? Now see here, this equation we can rearrange. Here bring T2 over here. So V2 divided by T2. V2 divided by T2. Bring V1 over there. Bring V1 over here. So V2 divided by T2 equal to V1 divided by T1. You can write it like this. V2 divided by T2 equal to V1 divided by T1. Okay, so V2 divided by T2 equal to V1 divided by T1 means V by T is a constant. V by T is a constant. We can call this constant K2. We already mentioned K1 in Boyle's law. So we can use another constant K2. So V by T is a constant. V by T is a constant. Bring T over there. So we can say V equal to K2 times T. Bring T over there. So V equal to K2 times T. Or you can say V directly proportional to temperature. This is Charles' law. This is Charles' law. Okay, volume of a fixed amount of gas is directly proportional to temperature at constant pressure. This is what I am saying here, Charles' law. Clear? So here Charles' law, we started from here. Charles did many experiments. He found that when temperature increases, volume also increases. When temperature decreases, volume also decreases. Okay, when we increase temperature by 1 degree Celsius, volume increases by 1 divided by 273.15. Okay, and he introduced this equation Vt equal to V0 plus T divided by 273.15 into V0. Then we can write like this. Okay, new temperature scale. This new temperature scale called absolute temperature scale, Kelvin temperature scale, or thermodynamic scale. Okay, then we use same derivation and we arranged like this, and finally we obtained V2 by T2 equal to V1 divided by T1. V2 divided by T2 equal to V1 divided by T1. V by T is a constant. V by T is a constant K2. So V equal to K2 into T. V directly proportional to T. That is Charles' law. Okay. Okay, next one. We have to discuss here isobar. Isobar mean here graphical representation volume against temperature at constant pressure. Okay, so volume against temperature, here we have different lines at different pressure. Okay, and here look here, we know here this is here we know here higher volume. Look here, this is higher volume. Okay, when you are moving this direction, so volume will be decreases. Okay, volume will be decreases. So here we know at a higher volume, at high volume pressure will be less, because we know volume and pressure are inversely proportional. So this P1 will be less than P2, P2 is less than P3, P3 is less than P4, P4 is higher. Okay. So this is the graphical representation here. Volume against temperature and pressure is constant. That's why we call this isobar. Okay. And here all these lines appears when you extrapolate these lines, and it will meet a common point. These are the different lines for volume against temperature at different pressure. Okay. And when you extrapolate this line, and it will meet a common point, and this point will be temperature minus 273.15. okay, and this is one imaginary hypothetical temperature. At this temperature all gases supposed to be zero volume. Okay, here this is the graphical representation, volume against temperature. These are the different lines at different pressure. When you extrapolate, when you meet this line straightly, and it will join a common point. This is minus 273.15 temperature, and this temperature is called absolute zero temperature. Absolute zero temperature means minus 273.15. This is one imaginary hypothetical temperature. At this temperature all gases supposed to be zero volume. Volume will be zero. So remember, this is one imaginary temperature. At this temperature minus 273.15, this temperature all gases supposed to be zero volume. This is called absolute zero temperature. Okay. And one more thing we have to understand here, Charles' law. We discussed now Charles' law. All gases obey Charles' law and Boyle's law at very low pressure and higher temperature. Okay, at low pressure and higher temperature, all gases obey Charles' law and Boyle's law. Okay, so these are the things we have to discuss in this video. In this video we discuss gaseous state, physical properties of gaseous state, relation between temperature and relation between thermal energy and intermolecular force of attraction. Also we discuss Boyle's law and Charles' law. Okay, so thank you for watching this channel. Next content you can watch next videos. Okay, thank you.